Welcome to our favorite YouTube channel DCD Electrical Knowledge. Master Study Guide Single Phase Reluctance Motors. The clever trick to constant speed without the DC bulk. The goal constant synchronous speed for small drives. The constraint, the small motors usually only have single phase AC. The magic, no DC excitation to the rotor is needed. The two main types of single phase synchronous motor. Number one, a reluctance motor, and number two, hysteresis motors. Now we are focusing on reluctance motors. What exactly is a synchronous motor? Like most motors, it converts electrical energy into mechanical energy. Electrical energy, that is AC supply, converted into mechanical energy, that is rotation, operated on AC supply. The catch, it only wants to run at one exact speed, no faster, no slower. The magic speed limit, synchronous speed ns, is equal to 120 f by p, where ns is equal to synchronous speed in rpm, f frequency of AC supply in hertz, and P is equal to number of poles. This is the speed of a rotating magnetic field. What exactly is reluctance? Think of it as electrical resistance, but for magnetic fields. In other words, reluctance is equal to magnetic resistance, which is highlighted. The figure shows clearly the golden rule of magnetic flux. Magnetic flux always takes the path of least reluctance. Figure shows clearly. air is equal to high reluctance. Steel or iron is equal to low reluctance. Flux hates air. Motor Anatomy Part 1. The stator. The stationary outer shell made with copper windings takes single phase or three phase AC power, creates a rotating magnetic field here, that is inside of the core. Motor Anatomy Part 2. The rotor. No windings, no magnets, no slip rings. Made entirely of ferro materials, that is iron or steel. This means zero core losses in the rotor and huge energy savings. Rotor design: axial versus radial. Valeria Habrovokova's experiments proved axial is better. Axial laminations refers to the components, that is laminations, oriented parallel to the axis of rotation, that is the picture. On the other hand, radial laminations refers to component, that is laminations are perpendicular to the axis of rotation. Narrow laminations evenly distributed flux. So lamination should be axial. Step by step operation. Stator receive AC power. Then a rotating magnetic field RMF is produced or born as per figure 3. Ferro rotor naturally aligns with the rotating magnetic field to find the path of lowest reluctance. Reluctance motor family. 1. Synchronous reluctance motor, that is synchronous RM. Number 2. Switched reluctance motor, SRM. And thirdly, single phase synchronous motor. Great for low power specific tasks. Variation A. Synchronous reluctant motor, synchronous RM, uses standard three-phase AC power. The rotor locks in and turn at exact synchronous speed with the magnetic field, known as the new giant in the electric world. Figure shows the synchronous RM. Variation B, switched reluctance motor, that is SRM, does not use smooth AC wave. Pulse of power are switched on and off to specific stator coils in a sequence. Relies heavily on exact timing. Super robust, very common in industrial automation. Variation C, single phase synchronous, runs on standard single phase main power, simpler construction, used for smaller specific purpose tasks rather than heavy industrial lifting. Variation A, synchronous reluctant motor, synchronous RM, uses standard three-phase AC power. The rotor locks in and turn at exact synchronous speed with the magnetic field, known as the new giant in the electric world. Figure shows the synchronous RM. Variation B, switched reluctance motor, that is SRM, does not use smooth AC wave. Pulse of power are switched on and off to specific stator coils in a sequence. Relies heavily on exact timing. Super robust, very common in industrial automation. Variation C, single phase synchronous, runs on standard single phase main power, simpler construction, used for smaller specific purpose tasks rather than heavy industrial lifting. Why use them? Massive energy saving, core losses are minimal compared to traditional induction motors. No rotor heat because there are zero copper winding. I square R losses is equal to 0. Simple, cheap, and indestructible rotor construction. Where do we actually use them? Industrial automation. SRMS offers great precision and robustness. Secondly, smart grid technology, capitalizing on higher energy efficiency. And third, electric vehicles, EVs, using synchronization repulsion motors to squeeze every mile out of the battery. Final exam check sheet. Reluctance is equal to magnetic resistance. Stator has copper windings, makes a rotating magnetic field. A rotor has no windings or magnets, made of ferromaterial. Minimal core loss is equal to huge energy saving. Axial lamination gives higher torque, requires VFD brain to monitor rotor positions. No more today. Next, we meet you in next videos. Please like, share, and subscribe my channel DCD Electrical Knowledge. Thank you.